All right, everybody, I'm so sorry about that delay, but we are going to get started here. So I just wanted to welcome everybody here to our Solid Edge Electrical Design webinar. I wanted to thank you all so much for taking time out of your day to join us. Today, we have one of CamLogic's application engineers, Jason Walker, joining us today, who's going to be presenting and walking us through. We are going to be having an open Q&A at the end of the presentation, so feel free to type in the chat as we go, and we will be sure to answer those questions at the end, all right? And I would also like to announce that we also have a discount promotion that we are going to be sharing with everyone at the end as well. And before we get started, I'm just going to run through the agenda real quick, and then we will have Jason take it away. All right, so we're going to have Jason do a CamLogic introduction, kind of explaining who we are and what we do. We're going to be doing an introduction to solid edge wiring and harness design, solid edge wiring design, integration with solid edge MCAD, solid edge harness design, and then of course we're going to be going into our Q&A. So Jason, if you are ready, you can go ahead and take it away.
Thanks, Ashley. So we are CamLogic. We've been serving the Siemens portfolio for 25 years. We've been heavily focused in the solid edge portfolio. We use the software ourselves in some of our other departments. We are a tier 1 supplier and of one of the big three. We also break our offerings into 4 different sections, and you can kind of see that based on our wheel here. We have the conceive for engineering and design, develop solutions. We do additive and subtractive manufacturing, as well as capturing with our 3D scanning services. We use this the Solid Edge portfolio throughout the process ourselves, and we use that expertise and knowledge to help serve all of our Solid Edge customers as well. So what I'm going to show today is the Solid Edge Electricals portfolio. It is a suite of softwares that is catered to creating wiring designs and schematics, as well as creating harness designs. I'm going to start by opening a project called that was given to us from Siemens. It was originally a company called WashTech, and this is the wiring schematic for a washing unit. To start with, I'm going to go over into this, one of the many pages of this schematic with the servo motor. You can see we have our design laid out here, and anytime I click on one of these devices, you can see over in the left we have our design tab with all of the devices and all of the conductors listed out. And one of the beneficial features and that helps keep you organized is it has all of it'll help cross highlight between the two. So if you click on a highway, conductor, or device, it will highlight in the design panel. But also if I select a device on if I select a component in the design panel, it will highlight that object in my design. It makes it easier to follow your design, make sure everything's going where it needs to be, and helps navigation. I'm also going to come over to this power diagram. So all of your diagrams can be multi-sheet if necessary. You have these references that show other sheets, and when you do have some of these references, you can easily view the related items and navigate to them. So that takes us to this third sheet, which has a few different components and isn't quite completed yet. But before we finish this design, one thing we need to do is create the design for this KM4. KM4 is a composite symbol and consists of multiple components, one of them being placed on this design. So in this design, we have a blank one here. So I can start by adding some of the necessary symbols. Now, when it comes to these symbol databases, sometimes they get pretty full, and there's quite a few different options in here. So we have this search bar at the bottom to help you locate what you are trying to search for. So I can search for pull and select this pull button, normally closed, and place that symbol here. And I'm going to need a second one, so I can just copy and paste that. The next thing I'm going to need is a push button. So I can go to the push button section and select the push button normally open symbol. Now the rest of the symbols are actually already part of the composite symbol for KM4. So first I need to place the coil and then normally open contact, or sorry, normally closed contact. So I'm going to realign these a little bit and make everything line up here. So next, I need to wire these all together. I can do that by selecting the wire command, or in my case, I'm using a hotkey. You can also come up here and click add wire. And there's also the option to have it repeat commands by holding shift. And it just helps with productivity and keeps your efficiency when creating the schematics higher. I do need to add in this last device here. And then just to make this a bit more readable and easier to understand, I'm going to add some chamfers onto the side of this wire for the corner. So the next thing I need to do is change some of these names. By default, whenever you add a device, it just gives you the next number sequentially. You can edit the default naming convention. However, normally it is just, whatever is the next sequence. So 73, 74, and 75. But in my case, I want to call this emergency stop 1. And then I'm going to name the second device emergency stop 2. One thing I also want to point out, and something that's very helpful, is that the wiring design software has DRCs, or design rule checks. One of these design rule checks prevents you from having duplicate names. So you can see that my emergency stop 1 is currently red. And if I were to press enter, it won't actually let me call this second device emergency stop 1. So I have to rename it and call it emergency stop 2. And then lastly, we need a push to start. And then the final thing is to add the actual device that we are creating the composite symbol for as reference. So I can double click this KM4, make sure I have the entire symbol, and place it. And then you can see after I've placed it that it gives me references to some of these other locations in my design. And I'm going to follow this one over to the other diagram. So now that I'm in here, this should look familiar. I'm back to my original design. And now that I've completed creating this composite symbol, I need to finish this schematic. I can copy and paste multiple components, which makes the, designing this third section here a little bit quicker. I do need to rename some of these things and relabel what the components are, since this is going to be a rotary motor. I can also edit the component that I have here. You can have custom properties in all of your components. In this case, this one is named power. And instead of 0.37 kilowatts, this one is a 1.8 kilowatt rotary motor. Next, I need to wire up those last 3 wires. So I can use multi-connect by wire to quickly add those, and then I just need to rename them. I also need to rename this device. Oh. And these 3 wires. You can see that I'm zooming in and out with this, red line. This is a tool just to help navigate quicker. Lets you zoom in and out in different areas of your design easily, and then by dragging the opposite direction, it zooms out to allow you to view your entire schematic. Another benefit of using solid edge wiring design is the analysis or simulation tools. There are 2 modes with simulation, both qualitative and numeric. Qualitative shows whether something has a current or not, but it doesn't show the actual numbers, whereas numeric simulation will show, voltages, amperage, things like that. This will just take a second, and then I can close a couple of these devices as a place to start off. Now you'll see in this design that some of the devices are green, whereas some of these are teal. The green colors are showing that there is current flowing through that device or conductor, and the teal shows that there is no current. It also, when you hover over devices, gives you what the current status of that device is. So for example, this green light is showing that it has current running through it. It shows the fact that it is lit, whereas this red light shows that it is not lit, and same with this orange light. You can also see for some of these switches, like the main control unit, whether they're open or closed, or the door locks. This one is currently closed, and same with the emergency stops. So one thing we can do is open this door lock and see how the simulation changes and what the responses are. So over here, you can see that the red light now shows that it is lit, and the same with the orange light. Another thing that can be simulated is a failure. So if I set the input on this door lock to closed, but I have a failure to stuck open, it will show that this device is yellow, which indicates that there's a failure, and shows the results of that failure, so that the red and orange lights are also still lit. If I then open this back up and remove my failure, the last thing that we want to do is test our emergency stops. So let's make sure, get this back to a running. All right, so our light is green. And now if I press or open one of these emergency stops, we can see what the result is. And you'll notice that the entire schematic goes teal, which means that there is no current flowing through any of it, which is the behavior we would expect from a emergency stop button. This type of simulation is very helpful to verify and make sure that your designs are working the way you'd expect, and double check and look for any potential issues. The next thing I need to do is add a couple of devices here. So I did have one of the, I did have a generic connector here, but what I really need is a part from my library. So rather than adding in just, because we can add connectors, we have plugs, inlines, and jacks. So if I do this, it's clicked. I add this plug, it's pretty simple to just, make a generic connector. But what I can also do is go to my parts library and search for one. So first I'm going to search for the type code of CONN for connector. And then I'm also going to filter again by the number of pins or cavities. And I'm going to set that equal to 2. And then if I press search, it gives me the list of connectors that match that criteria. And I can place the one that I need in my device. I am going to rename it to P3. And place this to match the others. The next thing I need to do is add the pins. So normally when you add pins, you can add them freebie, but because this is a library part, the pins are already pre-named and the count is already determined. And so I just need to place them on the connector device. And just like before, I'm going to do a multi-connect by wire and attach those 2 wires to the device. I'll rename these accordingly. Now, these wires are just wires. I don't really have a part assigned to them yet. So I'm going to add my library part here. So I click add. I already have the group name wire as a filter. I'm just going to filter here for some of these, and I'm going to choose this first one for the black wire. You can see the different properties listed in the attributes below. Click OK. And for this wire, I need to add red. So now that I have all those wires added to the device, I can highlight all of the connectors here and make sure that I have my harness attribute set. This allows us to indicate which devices we want to push over to the MCAD software. So in Solid Edge electrical routing, we're able to show all of the, we're actually able to model in the wires and connectors that are needed for our harness. First, I need to go into the subassembly that contains our harness. And then I can hide the rest of the assembly here. And so now we can see that. So we'll go into the electrical routing environment. And here we should be able to get started now. Now, the reason we had to add that filter is because we don't really want to add every single device. And this helps you control what you want to bring in and when. If you were to try to do an entire design all at once, it might get a little bit confusing. So this helps you by indicating that I only want to import the wash station harness. I can control and manage the devices a bit easier. So I'm going to bridge out here. Oh, first I have to add connected mode. Connected mode is a feature that is unique with Solid Edge wiring and harness, and it works with electrical routing, and it allows you to push the data back and forth between the 2 softwares. Pretty simple. So if I press bridge out now, instead of having me save out a file, it will give me a little report about what has been exported over to Solid Edge. So now that I've done that, I can click finish. And when these two arrows were green, it just is an indicator that there is new data. Now, what I want to say is, although I'm using this on a single workstation at a single location, everything's local for me, it doesn't have to be. You can actually have your electrical engineers and mechanical engineers in two different facilities if you wanted, two different, computers, of course. And this would also allow them to collaborate. There's even a cross-select feature that lets you select devices in one program and they will highlight in the other to make it easier to communicate between the two. It's a little hard to show it on one screen, but it is a feature that's available. So what we need to do now, and the reason that we bring our wiring information into the 3D environment, is so that we can route them in 3D space and get proper wire lengths and things like that. So we'll start by selecting these two wires and routing them through the existing path that already has the wires that belong to this connector. And so you can see that the wires have already started to take a bit of a different path. They go up through here and come out over here. That isn't quite what I want yet. I do want to add one more path. And so I'm going to show one of the paths that I had created at Advance and have these wires follow this as well. So just use my routing command again, or bundle command. Oh, I only selected one wire there. Oops. There we go. Now that I got both wires in there, you can see that they're both following it, and we can see the results at the bottom. I do need to clean up a couple of the ends of these wires, but that only takes a moment. And then after this, what I'm going to do is add in the physical conductors. One of the benefits to doing all this inside the 3D environment is that you can get an actual representation of what your wires would look like in 3D space. So rather than just having these lines or paths, once you have everything routed the way where you'd like, you can select your paths or for your wires and show the physical conductor. So you can see if I zoom in a little bit here, you can see that I have an actual 3D wire, and you can see roughly, the space that it would take up if there was any collisions between other parts, things like that. And if I right click on these wires and go into the properties, you can see a bunch of information such as that comes from the wiring software, such as, which component it is connected to, from which terminals it's connected to, and where it goes, as well as both the true length and the cut length. The cut length is the length of the wire that, after being adjusted for things like slack and for added length, depending on the devices it's connected to. Whereas the true length is the shortest length from point A to point, or the length of the path from point A to point B. It's also really easy to push any changes through between from wiring and harness design over to the 3D Solid Edge. Just as an example, I can change this wire from a red wire. Perhaps I want a blue wire. I can remove that. Select blue. Okay. And once I'm done, all I have to do is bridge out again, update my information with the update button, and then I will have to re-show the physical conductor, but you'll see that the line representing the wire is now blue. And once I re-add the physical conductor, you'll see that it is now a blue wire. Now, another advantage of this is that you can actually bring data from the Solid Edge 3D environment back into your wiring designs, in addition to your harnesses too. So I'm going to add the property onto my diagram for wire length. So for all these wires, I have the lengths. I am going to kind of move these real quick so they're a little bit out of the way. And now I can do a bridge in instead of a bridge out. And you'll see that the wire lengths have been updated. And these values all come from 3D Solid Edge, basically from where those properties that I showed just a moment ago. And then the last thing I need to do is finish routing. So although this wire does follow this path, I do want it to go through these clips. Right now it currently doesn't. So if I do click this, I can route it properly. All right, so now that our bundle goes through that clip, save again. And then let's just see if anything's changed much. A couple of the values have been updated, and we should have all our information. Another thing that it's useful for is when it comes to things like wire lists or bill of materials, we can add tables to our designs if we want. I'm going to show a wire list off to the side here because it's a rather large table. It shows all the information that you could want, and of course this is this can be edited, but it shows the name of the device or the wire, where it starts, what pin it's connected to, and then of course the device that it goes to and the pin that it's connected to there. It also shows the wire lengths and some other library information, such as the specification of the wire, the color of the wire, and the library part number. I'm going to delete this here. I just wanted to show the table. So the last thing we need to do is I'm going to close out some of these and create a harness design now. So I'm going to go and so if I go to design, new harness design, now it is required that I have a part number in here, and I do need to and then like I said, the part number is required. There's also some options in here, so like you can have add properties to your harnesses if you'd like. There's also some details in here that you can use, such as if you have multiple sites, you can have these harnesses have a site designated, maybe where it'll be manufactured. You can also have a customer page so that if they have a part number that they want on there, or you can divide up the harnesses between the customers potentially. And then there's also these extra details which you can define yourself. And then the first thing I'm going to do is actually change my border. The diagram that I'm going to have is going to be a little big for the current border. So I can quickly and easily switch to a bit of a larger sheet. And then I can do my import. I'm going to make sure that I have everything saved here. Gen. And you do have some options, but these don't really matter for the first time. There's, the option to replace or update, but since I don't have anything on my diagram in the first place, it doesn't change a whole lot. There's a lot of benefits to using this method for your harness. It saves a lot of time getting all of these, all of the devices onto your harness design initially. There is a little bit of cleanup, and but it saves an enormous amount of time getting all the devices and information onto the harness design. So I'm going to move the whole design off to the left, just to save some space. And then I can lay this out a little bit better just by dragging the nodes around. So if I can move that node there, this one down. And then this one is kind of the end of the longest stretch of our harness. So I'm going to move this one way over here. And then lastly, move this down to the left. This one will go. I'll also move this one down to the left. It can go straight up. Now I kind of have this laid out a little bit better. There's a few things I want to add. The first thing is off to the left here. I'm going to add an arc or a bend to this branch of my harness. It only takes a couple of seconds, a couple of clicks. And then I can specify what the radius and angle are. And it will, bend to the specifications that I gave it. I'm going to do the same on the right side over here. So that's starting to look a little bit closer to what I would like. I'm going to clean up a few things, make these more parallel, move some of these objects around. It's quite efficient and boost, it's quick to create the design that you want in the way that you want it to look. Now, all of these objects that you see, the names, the titles, the part numbers, things like that, those are all customizable. This is pretty close to what a default setup would look like. You have, the part name, and then because, these are multiple clips, you have the unique part name from Solid Edge. Otherwise, you'd have a bunch of the same one. There's also options, plenty of options on how you want the names and titles to be positioned by default. So the next thing I need to do is synchronize my harness with my design. So once everything's been saved, synchronize. And now you'll see that there's a bit more information. I got a couple of new tables, and this table's been populated a bit more. And then I also have a table in the top right corner. However, this isn't quite positioned right. It's very easy to go into your style settings to edit where something should go. Now that setting has been used before, but I have an offset of -10 millimeters in both directions, horizontal and vertical, and then I have it, in the top right corner. So if I press OK, you can see that it places itself just away from the edge of the sheet. You can also see that I have all of the wire numbers, the part numbers for each of them, where they start, and the cavity they start from, and then of course the device that they go to and the cavity they go to. It also has the specification and colors, and then there's an empty column for length. So that's another thing that we can do, where if we go to this calculate option, we could calculate the wire length and length for the course. Another feature that we could do, or another thing that we can add, is insulation or tape to some of our bundles. So here I will add tape, and overlap tape will be what I'm going to choose here. I can even go in here and select which of my tape parts that I want to use. I'll choose the black tape, and I can define in percentages how much I want the overlap to be. So I'll do 50% overlap, click OK, click OK. And then if I zoom in here, it's pretty small, so I can go ahead and make this a bit bigger. There we go. So now if I zoom out to more of a full-size view, I can still see the tape on my design. I'm going to add another similar overlap tape onto this bundle over here. Same as before, just grab my library part. This way to track the, which component I'm using. And it has all of the, you need to edit my overlap percentage here. And same as before. Now we can zoom out and take a look at what we've added here. And last but not least, I'm going to add one to this bundle, but I'm going to use a different type of tape this time. Base tape. I'm going to use the same tape part for it, but the way you specify how this is wrapped is the distance between your items, and I will do, I believe, 50 millimeters. I press OK. And because this is such a large harness, I kind of have to make some of these bigger so that they're visible, from a bit of a distance or zoomed out all the way. So that kind of, you can add things like tape and clips, grommets, splices, all of those things can be added to the design. And the end result is, all your tables are filled out, all your devices are accounted for, all the components are accounted for. And we can also have things like reports. So an example of one report is this complete BOM. So this is, of course, savable and printable, but it lists out all the part numbers. If you have it saved in your library, you have which supplier and what the part number is for them, as well as the quantity. You can see the wires and the tape, things like that. Even includes the clips. Perhaps one of the other ones is this. It's still the bill of material, but this one's separated out into the different types of devices. So our connectors are at the top. We have our clips, the insulation, and of course the wires and any additional components at the bottom. Just like before, there's a save and print option. We also have our harness wire list, which is similar to that table I showed before, but it has all of the components, the wire lengths, the specifications, etc. And that about does it for the completion, of a high-level run-through of the three main components of solid edge wiring and harness design. To review it a little bit, we started with a wiring schematic or wiring diagram. We added in some of the components, such the emergency stops, and we wired up one of them to the main control unit. And then we went through and modeled our wires in the 3D environment so that we can see them along with the rest of the assembly, just like this. And then we took the data from here and pushed that back into our solid edge harness design. And using that data, we were able to quickly pull in all the lengths of our bundles, wires, and it also included all the clips and other components. And then we were able to add any necessary harness components, such as the tape, or if we had any additional grommets or splices that would be necessary, we could add those as well. And then by synchronizing with the wiring design we had created earlier, we populate all of the data that's needed, and then it's just a little bit of fixing up the way it's laid out, and we're able to have a functional harness. Does anybody? So one thing I do want to bring up before I go into Q&A is this offering that Siemens has. So there is the offer of professional service for anybody who's interested in using solid edge wiring and harness design. If anything that you might be worried about in terms of support, or getting things set up like your libraries and symbols, or any of the processes, calculations, anything that you might want to have help with when it comes to implementing this type of software, this is available. Siemens has a resource and an expert that can assist you with that. It's just something that Siemens has an offer to help along the journey. That does it for me, so I'm going to hand it back over to Ashley.
All right, thank you for that great presentation, Jason. So before we go into questions, I do just want to go ahead and share the discount that we're offering for everyone who attended the webinar. We will be offering 25% off Solid Edge electrical design products, which includes Solid Edge wiring design, Solid Edge harness design, Solid Edge wiring and harness design, and Solid Edge electrical routing. This offer will expire after September 20th of 2023, and there is a 36-month term required for a full discount. Our sales team will be reaching out via email with more information to everybody who attended here in regards to the discount, and they will be able to answer any further questions that you might have in regards to that discount. So now let's get into some questions. So if anybody has any questions, go ahead and just put them in the chat there. We'll give a couple minutes for everybody to get their questions in, and then we'll get everybody their answers. All right, so go ahead and put those questions in there. All right, so One question that we have, are the wire lengths in the diagram automatically updated in the BOM?
Yeah, so you do need to get the wire lengths from your electrical routing from the 3D software, but once they're inside your wiring design, the property has been populated. They are automatically updated from there in any location that they'd be present.
All right, another question from Vance. If we are currently only doing schematics, which package would we need?
So that could be discussed with sales specifically to see exactly what which package is required for you. Based on the way you worded that, I would say wiring design, but I would reach out to sales and see which, so that we can discuss what your needs are, and we can get the specifics.
All right, we've got one more question coming in here. All right. Can the simulator simulate relays and timers?
Yeah, it can, and the library, of course, can be updated. Those are from Boston had relayed those from Nazar. Yeah, you can do relays, timers, and then of course the library can be updated. You can add new components, remove obsolete components, anything that would be needed to maintain your parts library.
All right.
And Jason McBride, I see your question there. His question was, in the harness schematic, what would indicate where your breakouts are? So those are things that you can, add yourself. You can decide what you want that indicator to be. And those are some of those, the styling choices that you can make. So you can add, add a symbol, or you could have it be text. Whichever whichever indicator you would like. I haven't checked specifically if it can be a dimension. I would have to look into that and get back to you, but I can certainly check and see what is capable. I'm certain that it's definitely something that's, I would say there's a high probability that it can be done, but I have to go test it myself.
All right, so if there are no more questions, I just wanted to thank everyone for attending the webinar today. And of course, if you have any further questions, maybe a little bit more in depth of a question, or if you come up with a question once you sign off of here, of course, please feel free to reach out to either myself or Jason, and we will be sure to get back to you on that. So, might have one more question here. No? Okay. All right. Well, thank you everyone again, and have a great rest of your day. Thank you so much for joining.